Dear students, I hope you are fine and doing well. Today I have come up with a very important chapter, dual nature of radiation and matter. Today I have to complete two important content of this topic. One is photoelectric effect and another is law of photoelectric effect. So let us begin with the photoelectric effect. So photoelectric effect. What is photoelectric effect? Suppose light ray of sufficient frequency or sufficient wavelength falls on a surface, then the emission of electron takes place. Very simple definition. Such phenomenon is called photoelectric effect. Let us write it. Whenever light ray of sufficient frequency or sufficient wavelength falls on the surface of a substance, then the emission of electron takes place. Such phenomenon is called photoelectric effect. This is very clear definition. Okay, I think you got it. Now let us start about the second content, that is law of photoelectric effect. I think you have understood the concept. Whenever light ray falls on the surface of a substance, and which type of light? Sufficient wavelength and frequency. Due to that, the emission of electrons takes place. And this emission of electrons means photocurrent. This is also called photocurrent. Now let us do the next content, that is laws of photoelectric effect. There are some certain laws. There are some certain laws which can be defined in some lines, in some points. The first point you can see, it's certain minimum frequency of incident radiation or incident light, below which the emission of electrons is not possible. And that certain frequency is known as threshold frequency. Okay. So in laws of photoelectric effect, that certain frequency, that certain minimum frequency of incident radiation, that is threshold frequency, due to which the emission of electron takes place. So I will write that there is a certain minimum, there is certain minimum there is a certain minimum frequency of incident radiation above which emission of electron takes place. That is, that certain frequency below which emission of electron are not possible. Okay. Such frequency is threshold frequency. Threshold frequency. I think you got it. Okay. There is a certain minimum frequency of incident radiation above which emission of electron takes place. But below that emission, that certain frequency below which emission of electron are not possible. Such frequency is threshold frequency. There is a certain frequency. Above that certain frequency, emission will take place, and below that, emission will not take place. Okay. So this is the first truth. The photoelectric. Now, the second one, intensity of incident radiation, amount of light ray that is falling in the space. Okay, and the kinetic energy of emitted electrons. If you talk about the kinetic energy of emitted electron, if you talk about the incident intensity of incident radiation, then we can say that incident intensity of incident radiation, more and more intensity of incident radiation, that gives more or more emission of electrons. That is, current increases. but it doesn't affect the maximum kinetic energy of emitted electrons. What I say in simple way, the intensity of incident light is directly proportional to the the emission of electrons. Greater the intensity of incident light, greater will be the emission, means greater will be the photo current. Okay. Now the third one, the maximum kinetic energy of emitted electrons is directly proportional to the frequency of incident radiation or incident light. The maximum kinetic energy of incident light the maximum kinetic energy of incident the maximum kinetic energy the maximum kinetic energy of emitted electrons is directly proportional to the maximum kinetic energy of emitted electrons is directly proportional to the frequency of incident light. Okay, means kinetic energy in the kinetic energy of emitted electron that is proportional to the frequency of incident light. The maximum kinetic energy of emitted electrons is directly proportional to the frequency of incident light. Okay. Now, the next one is at moment light falls on the surface, emission of electron takes place. Means the photoelectric emission is an instantaneous process. At moment light falls, emission starts. At moment light, incident light stops, emission stops. Means it is an instantaneous process. Instantaneous process. And in fifth, you can say work function. Very important. Work function means the energy required to emit the electron from its surface. The energy required for what? For emission of electrons from its surface. That minimum energy. The minimum energy required for emission of electrons is called work function. Okay, so a minimum energy is required by electrons, required two electrons, required two electrons to go out of the surface, to go out of the surface is called work function. I think you got it. So in today's lecture, we studied about the two important points: definition of photoelectric photoelectric effect, and another content, laws of photoelectric effect. So today's lecture is sufficient for two small content. Now we will do some another content of the same chapter in the next lecture. Till then, keep watching and keep studying. Okay, thank you.